Start in. Welcome back. It's our third week already, right? I think so, something like that. Um, Hopefully you had a nice Labor Day weekend. I had a lot of work to get done. I had plans, and then I said, it's a holiday, take a break. So I did, and I didn't do much work, but now I got a lot of stuff to get caught up on. But that's okay. It's okay. What we're going to get into today is the content from chapter 2. I'm going back, I don't know, I keep trying, the technology's not quite to my liking, but we'll see how this works. So I am recording this session, and I think if I stay active, it should all work out good. And get that out of the way. We will, so let's see, this is Wednesday. So last Wednesday, we had sort of a tutoring, a work in progress day to work through chapter 1. Hopefully you've gotten through at least 70% of it. Once you get to 70%, then you'll get the full credits for that homework and the quiz. I haven't looked at scores or anything yet, but again, it's just kind of keep going. If you haven't, we'll be able to work on those. And next Monday, so it's kind of switched off. Monday will become our sort of tutored math day. So Monday we'll work through chapter 2. If you still got questions from chapter 1, we can address it. So it'll I can't remember how, we had maybe 5 or 6 people here. So it's an opportunity. If you need to be here, you should be here, and you can get the assistance. If you're either done with it or you're going to get it on your own, it's okay not to be here. Again, attendance is not part of a grade. And as I said in the last class, sometimes it might, especially if you're commuting, maybe it's better to use that commute time to work on it on your own if you're doing well than to come here and then sit and maybe not get much help. So that's the part I let you do. But when you need assistance, you need help, that's what I'm here for. And the other classes started. So I've got a 10:30 class that's a Math 141. They're a week behind us, so we just did lesson 1. And so I forget what day we're on. Next Monday, they will also have an open lab day. So if you want it, if you need help, come at 10:30. I'll be here, and it'll be open session, and we will work on what you need to work on. Again, it'll be more individual basis. 10:30 until 2:40, whatever time this class gets, I will be here. So you'll start getting, and it will be that way. We'll do, because they'll be doing lesson 2 on the following Wednesday. We'll be doing lesson 3, and then the following day will be a tutored math day. So you've got that big block of time, and that's why I sort of scheduled it that way. The work days will be big blocks of time where you could come early if you're able to, come to our session if you're able to, or if you're doing fine, again, try to work ahead. If you get through it and you don't need any help, that's fine too. So you get a day that you could do some other stuff, maybe Spanish or whatever classes you're taking, right? So the goal is to get you through everything successfully. Any questions that have come up since we started about the course, about life? Does anybody know what the Mega Millions numbers that will be coming? I bought 3 tickets for 3. I didn't win it. Nobody won it yet. It's like 600 million, but it would be nice, right? Yeah, I could do a lot of stuff with that money. But so if you get I keep saying, angels come down and tell me what numbers, but they've been mum, no help. Okay, so today we're going to take a little different approach. Oops, that's on. Why is it? Oh, got my pencil upside down. There is a pre-recorded lecture from previous times, but what I do with this one is I'm going to, I take a slightly different approach. I am recording this, but I go to the textbook because I want you to see sort of an example of how you could use a textbook to learn materials. So part of this is, yeah, it's a math class, but it's also how can we learn? So we'll let this come up, and I'll show you that this is going to give us an outline. And let's see. So what we're supposed to do in this section, only 4 things. So we're supposed to solve what are called one-step, two-step, and multi-step equations. So we're going to look at some examples of this, and kind of, I can do that without a PowerPoint. Just do that. Recognize a linear equation, identify its rate of change, initial value. Okay, so we'll do that too by looking at linear equations. We'll solve a few application problems using equations. And we'll also be able to calculate slope and interpret its rate of change. So we're going to do 2 and 4 together. And I'm going to use the techniques that we started on that first week from ancient India 3,000 to 5,000 years ago. Not formulas. I'll show you the formulas, like the slope formula, all that stuff that you probably learned at some time in your life. But we're also going to do it in a visual sense from ancient India. And it's the way that works for me. Because again, I'm dyslexic. And using formulas, I oftentimes plug a number into the wrong part of the formula, and then it's all messed up, right? That's what, and some people are very good at using formulas. I'm not. So we'll look at both ways. So there'll be a visual way of doing things and such. And I'm also going to introduce you to a tool called Desmos that's going to help us verify these answers. The way we're going to use the Desmos app, it's an online calculator. You can actually, you can download it from the App Store to either an iPhone or an Android, so you can have it on your phone like it's a little calculator. We're also going to use that again in Chapter 4. So you're going to see that this will be helpful that when we go through, if you learn how to use it here. We'll also use it again in Chapter 3 for a slightly different purpose. But this will connect all 3 lessons together. So as we go through this, we'll make that all good. Okay. So what do I need to do? I need to get my whiteboard. And I forgot. Oh, I know what I do. I just use Microsoft Word. Because it's got a draw feature. So it actually makes a fairly nice whiteboard. Bigger. Okay. So what we're going to start off with is thinking about this symbol. What is that symbol? Equals. What does it mean for well, let's look at the geometry of the equal sign. If you've got an equal sign, what else do you need to have?
Don't they have like greater than and equal to, less than and equal to?
We have those, but yeah, so those are different symbols. But where do you just see an equal sign sitting out by itself? You need some numbers. You need something on the left and something on the right. Sometimes variables could be there too, but you need other things. You need something here and something here. And then we could also have inequalities, which we will get to a little bit later, but we're not going to spend that much time. But an equal sign is something that's in the middle. And what does equals mean? What is it telling us about those 2 sides? They're the same. They are identical. They are the same. So I might have an X here and a 5 here, and they look different, don't they? X looks different than 5. But the communication is X is 5, 5 is X. They are both, I could use them interchangeably. So that's what an equal sign means, is they are both the same thing. Okay, so let's take a look at this. Would you agree if I have 3 equals 3?
Yeah.
That seems reasonable. And they even look the same pretty much. 3 does equal 3. They're the same thing. If I've got the same thing on each side, if I were to add something, let's say add 2 to this side, How do I keep them equal? You have to add the 2 to the other side. So I can do anything I want as far as addition as long as I do it to both sides. Okay. And this is in life too. You got 2 little cousins. You buy one of them an ice cream cone. What do you better do for the other one? You had better buy them an ice cream cone or you're going to have problems on your hands, right? What you do for one, you do to the other. Same thing to same. So keep them equal. And make sure that those scoops are the same size. Otherwise, he got bigger, more. He got more than me. I was that kid too. Okay, so we can do this, and then yes, we get 5 equals 5. We've maintained the equality. Could we do the same thing with subtraction? If we took 2 away from one side, take 2 away from that, we'll maintain that equality. Multiplication works the same. If I multiplied both sides by 2, 2 times 3 is 6, 2 times 3 is 6. If I multiply by, so I can do, the key is I can do anything with an equality to one side as long as I do exactly the same thing to the other. Okay. And that's the whole basis of what we're going to do in this first part. So if I have 3x equals 8, and I want to know, and that now this idea that x is not just a letter, but it's a letter that stands for a number, right? It's an unknown number. So it's a variable in that sense. What number would go there that makes this work? Now, this is the part of algebra where I ask, how many of you were sort of rebellious youths? Your mom said to do this and you did that. Always did the opposite, right? You're that kind of person, you're going to be good at algebra because instead of algebra is also about what we want to do to that side is we want to undo multiplication. So what's the opposite of multiplication? Division. So if on this left side, if we divide by 3, we have now undone that. 3 divided by 3 is 1. We kind of get the variable part by itself. But if we're going to divide one side by 3, what do we need to do to the other side? Divide by 3. Okay. So it's the opposite, but it's to both sides. So then we get x equals 8/3, which is a perfectly good number. Call it improper fraction because the top's bigger than the bottom, but it's perfectly fine. We could leave it that way. You could also take 8 divided by 3 and turn it to a decimal. It just depends on what the answer is asking for, whether it's asking for an exact answer. We take 8 divided by 3. What do we get? It's going to be like what? I think it's 2 point. That would give us 6 with 2 left over. So 2/3 is 6, 6, 6, 7. So a bunch of 6s and then always rounds off to a 7 at the end. So we could also write it this way. But what we just did is we found out what x is, right? X has to be this number, 8/3, 2.6667. And then if we plugged it back up here, 3 times that, we would get about 8. Or pretty close, because if we round it, we don't get exactly 8. We might get 7.999 something, okay? But what we did is we solved this equation for the unknown. So far, so good? Any questions? That's all. This is what's called a one-step equation, right? We just did one thing. So if we are multiplying, we divide. What if we were adding? We want to subtract. So see, that's good. Whatever mom says, do the opposite. It's kind of my mom's passed on, but now she's probably watching it now, so I better be careful. I was trying to be a good kid, but you know, hey, don't eat the ice cream. No, I gotta eat the ice cream. Don't steal the cookies. I gotta steal the cookies. Okay. Add? No, I gotta subtract. And we just do it. We get away with it as long as we do it to both sides. That was my problem. I had 3 brothers, and I would make a partnership with one of them. We were good. We keep it. Mom never found out from us, but it was the baby. He always told on us. And he said, come on, we had this plan. It was working. We had the cookies. She didn't know anything about them until you told them. So we always get in trouble that way, but okay. So whatever you do to one side, do it to the other. The one side is we're going to isolate, do the opposite of whatever they're telling us to do with the variable. They tell us to add, we subtract. They tell us to subtract, we add. They tell us to multiply, we divide. If they tell us to divide, what do? We multiply. There, we're getting it. Just always do the opposite. That's all there is to math. So we multiply by 3. 3 divided by 3 is 1, so that's taken care of. If we did it to one side, we got to do it to the other. So x becomes 6. So that's all. That's a one step. That's the first part of our thing. If we do one step, how about 2 steps? I'm going to come up a little bit, have a nice sheet of paper. So if I had 3x plus 2 equals 5. Now we can see to get the variable by itself, to figure out what that variable needs to be, I've got to get rid of 2 things. Now here's the other thing. How did we teach you as math teachers to do math? Order of operations things. What is the order of operations? What comes first? Please excuse my dear Aunt Sally. So PIM, please, parentheses, exponents, multiplication, division, addition, subtraction. Please excuse my dear Aunt Sally, or just PIMDAS if you want to think of it. Well, we don't want to do that. We want to do it backwards, right? We want to do the opposite. So this I pick up from one of my colleagues in the calculus series. We want to do SAD MEPS. So we do everything backwards. We start with subtraction, addition, then multiplication, addition. So we're going to do the order of operations backwards as well. So instead of starting with trying to deal with the 3 times x, we deal with the plus 2. Again, usually order of operations, if I gave you x, you would multiply first and then add. That is the way to do it. But since we're solving, we're doing everything backwards, right? Anybody work on mechanics, like an engine? You want to take an engine apart, you start from the outside, take it apart. When you want to put it back together, you have to start from the inside and work out. Because once you got it together, you can't put that screw that you forgot back in the middle without taking it all apart again. So there's 2 directions. We are undoing things. So this is just, do I divide first? Nope, I'm going to subtract first. And if I subtract the 2, because that was addition, I do it to both sides. So we'll see this becomes 3x plus 2 and minus 2 is 0. Adding 0, nothing happens, so we just leave it off. 5 minus 2 is 3. And then now, this is why it's called the 2-step. There's another step to do. What do we do with that 3? Just like we've been doing, we divide it. We do the opposite. So we're going to divide by 3. But if we do it to one side, we got to do it to the other side. This cancels. This also cancels, but it's not 0, right? 3 divided by 3 is 1. You could think if I take 3 times 1, I get 3. 3 plus 2 is 5. It works. So that's the nice thing about this solving equations is once you have your answer, you can always go back to the original, plug it in, and do the math forwards and check your answers. Okay. Yes? Yeah, in a sense, yeah, it would. It would, yeah, definitely. And here's another 2-step that might look like a 1-step. What if I had 2/3 x equals 7? Now this could be either a 1-step or a 2-step. So what am I doing to that x? I'm multiplying. I can either think of it as multiplication by a fraction of 2/3, or I could think of it that I'm multiplying by 2 and then I'm dividing by 3. So I could break it down into 2 pieces. So I could also think of this as, oops, I could Well, let's change colors while we're at it. Let's go with dark green. I think of this as, oh, go over to the pen. Think of this as 2x. Oh, I didn't change my color. That's okay. Divided by 3. Now, working with fractions is typically where, I don't know, I feel a little bit more stressed out when I'm working with a fraction than when I'm working with whole numbers. But I could do this in one step. What do I have to do? Instead of dividing by 3, what am I going to do? What's the opposite of dividing by 3? Multiplying. So that means that it goes in the numerator. Instead of multiplying by 2, I want to divide by 2. So that means it goes in the denominator over here. And notice what's going to happen. The 2 is going to divide into 2, so that cancels out, becomes 1. 3 divided by 3, that's going to cancel out, and I'll just be left with x. 1 times x, that's what I want. But if I do this, I multiply by the reciprocal on one side, what do I have to do to the other side? Same thing, I've got to multiply by 3 over 2. And again, think of 7 as a fraction, it's just 7 over 1. 7 times 3 is 21. 1 times 2 is 2. And so our answer is just x equals 21 halves. Or if you do the math on this, I think that's going to be about 10.5, 10 and a half, 10.5, or 10 and a half with a mixed number. Right? So either way. But see, we could think of that as a one step. And what I think you'll find is if you can think of it just multiplied by the reciprocal, it's an easier way to go through than doing it in 2 steps. Because if you do it in 2 steps, maybe you get rid of the 2 first, or you get, anyway. But when we got a fraction, just multiply by the reciprocal, it gets rid of the fraction completely. But if we do to one side, we got to do to the other. So far, so good? Making sense? So we got a number of the questions will be similar to this. So we got a 1 step, we got a 2 step. Again, if we're adding or subtracting, we do that first, and then we do the multiplication division. Now there's one more, and I don't think I think there might be 1 or 2 questions like this. But the last thing we have as far as equations is, what if we had something like this? So how is this equation different than the ones we've done before? What's different about this?
We have like terms on both sides.
Very good. There's a variable on both sides, like terms. So they're like family, but they're separated by the river in the middle, that equal sign. So I always say the first thing, now there's more than one way to do these things. That's the other thing with algebra. I always say get the family together. So you get the like terms, let's reunite them. Because that's usually the part that's getting, that if you're looking at this and you're saying, oh, I got an x on both, I got 2 x's, what do I do with these? But the fact that they're like terms, we can bring them together. I can get 3x and 4x together. How do I do that? Well, to get it off of this side, I have to do the opposite, right? So if I subtract 3x, that's going to turn it into 0, kind of make it disappear. But what I do to one side, I got to do to the other. Now, I could have done the other way. I could have subtracted 4x from both sides. That would work as well, but then I've got a negative x. I don't like negative numbers. I don't know about you. I'd rather be positive than negative. Sometimes I am negative, but I try not to be, okay? So if I can help it, I try to be positive. That's my first choice. And so that's the first thing we do. So that's the only thing. So when you have an x on both sides, we have the power to do anything we want to an equation as long as we do it to both sides. That's how this all works. And how did I know to subtract 3x? Well, I've been teaching math for 26 years. They've been paying me to do this. I got good at it. Okay. So if you ever want to get good at something, get somebody to pay you to do it. You'll get real good at it because, so that's, so this becomes 0. This stays 2. This is 4x minus 3x. They're like terms, so this is just now 1x. And all of a sudden, we've got it down to something we've been doing. Okay. Now, I remember when I was learning math, this was harder because it was the x is on the wrong side is the way it is my thinking, right? I'm used to having the x on the left side. It's not really on the wrong side, but for me, it was confusing. So what I can do, what I found with an equal sign, if A is equal to B, what do you know about B? B is also equal to A. So I can flip this at will. And since it's more comfortable for me, I'd say, let's do this as x minus 5 equals 2. Oh, that feels so much better. After you do this a while, then you'll get where you can work both ways, and it's okay. And if you're already there, that's fine too. But I started doing this, and it made math much easier for me. Because the one above it caused me stress, and it was harder. This one, just add the 5. Because I kept wanting to do something like subtract the 2, and then I'd get 0 here, and so if I just bring the x over to the left-hand side, I found it was easier for me. So again, do what works for you. But again, whatever we do to one side, we got to do to the other. Now we solve for x. We could go back to the beginning. We could plug in 7 for each of these, and we'd find that we'd get a number that's the same on both sides. And it works. Again, that equal sign just tells us both sides are the same number. And you'll find that 7 is the number that makes them both the same. Over here, it'll give us 21 plus 2 is 23. 4 times 7 is 28. 28 minus 5 is 23. Yes, 23 equals 23. So it works. So that's the nice thing about these is once we solve, we can always go back and check by plugging it in, and it will work. And that's one whole tick off the thing. Is that's all we have to be able to do is solve equations. And these are called linear equations because as we're going to see in the next step, these all, when we graph them, they become straight lines. Okay. So far, so good?
Yeah.
Wonderful. Let's do this. So that's one whole series. We'll go into that. I'm going to get a fresh page. And we'll just jump into this. We're going to look at linear equations. Now, when I mention linear equations, does anything come to mind as far as an equation that's linear? What comes after this? Y equals, there we go. And yeah, if you haven't had an algebra class in a while, this doesn't, but it's mx plus b. So we've been kind of working with these. An example of this might be y equals 3x plus 5. So that is a linear equation with two variables, an x variable and a y variable. Now we've been working with just one variable so far, with just the x. We were solving for x. What we're introducing now is now we have two variables. what we end up getting is we get, there'll be two numbers that are unknown that we're looking for. If I give you the x, you'll be able to figure out y. So if I tell you x is equal to 1, what would y be? 3 times 1 plus 5. Right, just kind of put an x. So y has got to be what? 3 times 1 is 3. 3 plus 5 is 8. Okay, so I get the point that when x is 1, y is going to be 8. And we list that as an ordered pair. Just kind of a shorthand. X goes first, y comes second. It's alphabetical, X, Y, Z, right? X is always first. But is that the only answer? Is that the only solution for this? No. If I say, I were to tell you that x is equal to 3, I go through the same process and I'm going to get a different value for y. Three times 3 is 9. 9 plus 5, oops, getting beyond my 9 plus 5, 14. And so the point 514 is also the line. Okay. And again, there's a lot of other ones in there, right? We could just keep putting in numbers for x, we'll get the number for y. What we will find out is that if we were to make a graph with the horizontal axis being the x, the vertical being the y, and we plot these points as 1, 8, let me put 8 here, we'll call this 8. And then, oh wait, 514, no, see, this is where I have these copy errors. Did anyone catch me on this when I put 514? Did you think that was strange? This point should not be 514. What should it be? 314. Let's see, I was pulling up, I saw this 5 and I put it. So I get lots of copy errors, more than I would like to get, but if I pay attention, I do better, but I don't always pay attention because my mind likes to go all over the place. Okay, so, okay, 314. So then I go 1, 2, 3. There's 8. 14 would be maybe a little higher. What we're going to find out is if I were to plot all these points like 2, see this, if I can do 2 in my head, 2 times 3 is 6, plus 5 is 11. It would be about here. What we'll find is that all these points are going to be on a line. And that's my best ability to draw a line, so it should connect all the points. We'll find that it's going to cross the y-axis right here, and that's where x is 0. So if you put in 0 here, that means y is 5. And I'm maybe not real accurate, but so linear equations, they become lines. X and y are changing, they're variables. But what we see here is that when we have this linear equation, there are two important parts. The number in front of the variable, the x variable, we're going to call that the slope. And it gives us the steepness of the line. If you think of the slope in terms of being a fraction, in this case it would be 3 over 1, what that is telling us about this line is that every time, well, we look at it as rise over run. So if I go up 3, 1, 2, 3, that gets me to 5, I would run 1. And so that gets me to the point 1, 8 from the point 0, 5. And if I rise 1, or if I rise 3 more and then run 1, I would be here, which is the point 11, or sorry, x is 2, y is 11. So 8 plus 3 is 11. 1 plus 1 is 2. And this last one that we found, if I rise 3 more, I'm up to 14 in the y direction, and I run 1, so I'm at 3, 14. So we see that this equation also tells us how that line is changing from one point to the next point to the points on down the line. So this is linear equations. If I have it in this form of y equals mx plus b, the m is our slope, and the b tells us where we're crossing the y-axis. It's telling us, because that's the place where x equals 0. So the x goes away, that's all that's left. Okay. So we could just, if I give you an equation, we could actually draw the graph, and we can go from there. So part of these activities, we're going to give you linear equations. And we're going to ask you for what is the slope and what is the either initial value, which means starting value, or the y-intercept. And we're going to be able to tell this answer. What is the slope? It's the number in front of the x. So what is our slope here? 2/3, exactly. We just see it, we write it. And again, can you visualize this? Is this line going up or down? It's going up because it's positive, right? I go up 2 and over 3. If it was going down, what would need to change? The sign. It would have to be negative. So any negative slope is going down, any positive slope is going up. And again, that's one of the questions. Also, if we're calling it going up, that's also called increasing. If it's going down, that's also called decreasing. So just vocabulary, and you'll need to do that. How about its initial value or its y-intercept? Well, that's the place where if we put in 0 for x, right, this goes away, we get y equals -4. So we could either just put in -4. If it wants it as an ordered pair, it's the ordered pair 0, -4 with parentheses around it. So we could also list it as a point. And again, it may ask for it either way. Are we okay with that part? Again, just to visualize this, we could also graph it just from this information. So the initial point is where we're starting. So we're starting down at -4. Y is -4 down here, say. And then we're going to rise up 2, 1, 2, and we're going to run 3, 1, 2, 3. And we would rise up 2, 1, 2, we're up here, 1, 2, 3. And we just kind of keep going up 2 over 3. We wanted to, if we drop 3 or drop 2, 1, 2, that's negative, so we go back 3, 1, 2, 3. So that could be thinking of it as -2 over -3, which is positive 2/3, right? So we could do all this, and then again, we connect them all and we see we have a line that I can't draw. In fact, actually, I got an F in my first college class because I couldn't draw a straight line. I was taking a 1-credit drafting class, and I could not draw a straight line to save my life. So I took the F first semester. I thought I was going to drop out of school, so I didn't care. But then my dad said, okay, you want to drop out of school? Then you start paying your own insurance and you start paying rent. Oh, I got to go get a job. Okay, I'll go back to school. It was easier than getting a job at those days. Anyway, we okay so far? Making sense? So linear equations. So we talked about, so now we're going to work backwards a little bit. How do we get that equation if maybe we only have 2 of the points on the line? I'm going to show you the ancient way of doing it. So let's say we've got a line that goes through the point. Well, somebody give me, I'll do this like we did the first one. Someone give me your favorite point. Any point. That's a coordinate, 5. What do I need to make it a point? I need a y. Every x needs a y. 3, 5, 3. Okay, so here's a good point to start with. Somebody give me another different point.
1.
1, 6. So again, we could come over here and draw this. So 5, 3 would be, let's do it in maybe black. 5, 3 would be a point about here. And then 1, 6 would be a point about there. So we should get a line that's going downward. So what kind of slope should we have? Negative. We should have a y-intercept. If 1, 6, it should be like maybe 7 or 8 or something. It's going to be bigger than 6 because it's coming down. So this just gets us to visualize it. Let me show you how we can find out what this is. Again, we'll use this formula that the slope is really, right, m is equal to y2 minus y1 over x2 minus x1. Does that look familiar to anyone? Maybe. It's okay if it doesn't, because that's not what I use anymore, because I always make mistakes when I use it. So what I'm going to do is notice that these points, they have a x is first and the y is second. Okay. We're going to be able to do this by something called, in India, it was in Sanskrit, the language Sanskrit, so it sounded differently, but it translates as vertically and crosswise. Vertically, crosswise. So what they did is vertically, they would subtract the 2 coordinates. So straight down vertically, they're going to subtract. So 5 minus 1 is 4, positive 4. I was going to do negative 4, but it's just positive 4. And then 3 minus 6, negative 3. Good. So that's the vertical part. The crosswise part is we're going to take the x and tuck it underneath the y. This is telling us our slope is negative 3/4. So we got the negative part from our drawing. It's going down, but look at this. This is the point 1, 6. This is the point 5, 3. And if we draw, what did we do? We drop from 1 to 5. Wait, did I get that backwards? 5, 3. Oh, okay, yeah. Okay, so we're going. So the y is the vertical part. So this is my problem. Is I keep switching back and forth, and I get my x and y's confused. And so we go from 6 down to 3, right? That means we dropped 3. We went down 3. We're going from 1 to 5. It means we run positive 4. And isn't that what the slope is telling us? Go down 3 and then over 4. Okay, so that's the way to do it. We can do it this way, vertically, just line up the points, straight down, subtract them, and then tuck the x underneath the y. You'll never have the problem. The way that, if you were taught this in an algebra class, was to use this formula. And I'll show you it's really the same things happening, but you've got to put y2. I don't know, you could call either one of these points 1 or 2. Let's call this 6. That's y2. So this would be y1, 6 minus 3. The denominator, we do x2. So this was y2. So we'll call this x2. That's 1 minus x1, which would be the 5. See how I have to kind of go touch each of those to make sure I get them in the right spot. 6 minus 3, we're still just subtracting the y's, positive 3. 1 minus 5, that's a negative 4. We still get the same answer, the negatives in the different place, but that's okay because, again, depending upon what direction we're going, we still got the same numerical value that this is a slope of negative 3/4. So we could use the formula method, and if that's comfortable to you, it's perfectly fine to go ahead and keep using it. But if you've had problems with that in the past, or if this is new, use the vertically and crosswise, and it'll make things probably smoother. It's what works for me. It's the way I do it all the time now. I don't use no formulas. Okay. How do we get the y-intercept though? Well, there is also a Vedic way, but I tend to mess that one up. So what I do is I say, okay, I get y equals negative 3/4 x plus b, right? Y equals mx plus b, and I figured out the slope already. I got 2 points here. I got 5, 3 and 1, 6. So I can, if I plug in 1 for x, then y has to be 6. If I plug in 5 for x, so I can plug in one of the points anyway. Let's take 1, 6. So y is going to be 6 whenever x is 1. And what I can do now, just like I was doing before, I've got one unknown, which is b. I can do my solving equations. So that was that first part we did. Now it's a little messy, but what's 1 times negative 3/4? It's still negative 3/4. We need to add 3/4 to both sides. How many of you like adding fractions? 1. Most of us don't. How would you like to add decimals? It's better because I could use my calculator. So I could take 3/4. 3 divided by 4 is actually going to be negative 0.75. Okay, so you could do it that way. So I add 0.75 to both sides. And that's going to give us that, do it up here, that b is equal to 6.75. And notice from our picture, yeah, we know it had to be higher than 6 because that's what's happening. So it's kind of like the picture, that's just a sketch helped us out. Sketch helped us out. Okay. And this is, I was working without a net, nothing up my sleeves. I got them hold up. You chose the points. This will work with any points. And this was not necessarily a well-contrived one because we ended up with a fraction. I'm going to show you one other way we can go about. We're going to use these same 2 points. We're going to come up with the same thing, but I'm going to show you how to use the Desmos graphing tool to do basically the same thing. And you can use it on your homework. So again, I've shown you an ancient way, away from ancient India, 3,000, 5,000, or 5,000 years ago. This is how they were doing it. I've shown you a method using a formula that you probably, if you've learned it, you've taken an algebra class in high school or someplace else, you've probably seen that before. And now let's go ahead and take a look at Desmos. And again, we will be using this multiple times, multiple ways. And if you read through, I think it's not till chapter 4 that it'll show you, but they will show you how to use a TI-84 calculator to do this. And it's a lot of steps, but I'm going to show you, it's not so bad with this. This is a more graphically oriented tool, and this is what we can use. I'm going to get into Desmos. Shrink this down. Let's see. Yeah, good. Okay. What I'm going to do is start off with, I want to enter the points. I want to tell Desmos what the 2 points I was given, because I want it to find the equation for me. So this is a little different. In fact, actually, I had to search a few videos to do this. But what we're going to do is we're going to give it a table of values. And we want x1 and y1. So these are our points. What was our first x value? It was 5, and the y value was 3. So I'm going to enter that in, and notice it it put it there, just like I was sketching. So it's sketching it for us. Our second point that we came up with was 1, 6, and it put it there as well. You can say, oh yeah, that's looking right. So now what I want Desmos to do is I want it to figure out what is the equation that of the line that would connect those 2 points. And Desmos is actually pretty good at this. So I either click down here and it gets me a place where I can put in the equation. I could push on the plus, and what I want it to do is find an expression. But either way, I get this site. What is the equation of a line? Isn't it, didn't we say it was y equals mx plus b? We did, but it didn't draw the line. Well, here's the thing. This is not x, this is x1, and this is y sub 1. Cool part is I can do that with Desmos. When I enter y, let me back up here, I can just type in the number 1. I don't even have to say it's going to be a subscript. It will automatically do that for me. Look, it made it y1. It says, okay, take those points. Now, my stuff disappeared, but it's still there. But I just need to come over here and also do x1. I hope. Whoa. Good. Oh, well, I never had this happen before. What should I do? Probably go back and enter them. So that was 5, 3. Let's see if it'll let me do this. Let me do this. What? I've never had it happen like, oh, I know. I think if I change this, so, and this is just a technical side. It doesn't really want the equals, it wants the approximate symbol. The approximate symbol, so let me do this. Oh, there they came back, they were still there. Okay, first time I've had this happen. I want the approximate symbol, was a little squiggly, and I'll show you. It's on your keyboard, probably next to the 1 key at the top. It's a little squiggly thing. It's called a tilde. I call it the squiggly. You can also, in Desmos, there's this keyboard, and it is, you go to the ABCs, it's over here. So it's this little squiggly thing, and it'll put it in, and look what it does. If you tell it approximately, then it tells it it needs to calculate that line. So that's the part I sometimes forget. I always put the equals there, but that blows things up. So we don't want equals, we want approximately. And what Desmos has done a couple things here. Now remember all those steps we went to. We gave it the 2 points. We typed in this general equation of a line, y equals mx plus b, but we just remembered to put the tilde, and we remembered we needed x1 and y1. If you do this a second time, this might be like x2 and y2. It's just however many tables, you have the same thing. But look what it gave us. It gives us a slope. Remember, we came up with -3/4, which is -0.75. It told it to us. That's why I like this one. It does all the work for us. And it's got the y-intercept 6.75. That's the same thing we figured out, right? We went through all the steps. We come back here. That's exactly what we got over here. We got that. We got the slope, -0.75. We got all the same stuff, but look at all the work we had to go through to get there. With Desmos, we just needed to give it the 2 points, and it took it from there with that tool. And we're going to use that. What we do that in 4, we have more than 2 points. So we've collected some data, and we're trying to get the line that fits them the best. That's what Desmos will do for us. So that's where we're getting to chapter 4, is we're actually going to look at ways of, if we were doing research and collecting data, how could we figure out sort of a line to predict what's going to happen? So we go from just sort of a simple equation to using this tool that's going to actually put us in the seat of being a researcher. They call those people doctor. So we went from being just people who are finding linear equations to doctors in a single step. Um, and I mean, literally, that's all. The only difference between someone who has a degree and doesn't, they know the right tools to use. That's what school's about, learning to make decisions and learning about what tools you can use to make those decisions. And that's what this class is we're giving you tools that you can do very advanced stuff. And then again, we could click up here. We can see the y-intercept is that. Get another x-intercepts down here, but we've got our equation here. So some of the questions, they will give you the 2 points. You can get your equations for the lines right using Desmos. You can do it by hand. You could use formulas. So multiple ways to do it, but always a way to check. Thing I like here is we also get the visual. And notice they've done a much better job of drawing straight lines than I was doing. It looks pretty. Screenshot. Okay. Questions?
What is the little 1 on the bottom?
The 1?
Yeah.
It connects it to the table. So notice this table is set up that this is x1 and y1. And it's just the way that Desmos works. Every table, and if you do another table, like if I say, give me another table, it's going to get x2 and y2. So let me say, give me another table. There it is. So x2 and y2. So I would have to reference x2 and y2 if I wanted to use the data from that table. Okay. And if I do another one, x3 and y2. So it's just referencing which table you're getting your points from. You need this little tilde. And again, we're going to do this in chapter 3 and chapter 4, but we do slightly different equations. But this is a tool that Desmos is able to take the points we give it and fit a curve or a straight line to those points and give us the equation. It's a great way to do mathematics. Right? Okay. And I think we need to do some applications. So let's go into the quiz because we've got the tools. We've got this, finding equations of lines, solving equations. We should be able to get all the way through the homework and the quiz now. The applications is just we got to think through these skills, but those are the skills we need. Okay, so let's see what's on this quiz. And the quiz is a short way of telling us what's in the homework. Homework just gives you more questions, more practice with it. Okay, where's my water? It's right here. Okay. How do we do this one? Again, it's probably best not to try to do the quiz at the same time I'm doing it because your numbers will be different, slightly different most of the time. But we need to solve this equation, which means get x by itself, so we know what x is. So what do we do first here? Very good. We're dividing by 5. Might think try to add the 8, but it's not really accessible. So it's like get to the easy stuff. So let's multiply both sides by 5. And now you're wishing that you could write on your computer too, right? Actually, you can. This is what do they call this? This is an extension for Chrome. I think I pay $7 a year for it so that I can have the color. You can get it for free if you don't want the color, but if you want the color, I like color markers, so I pay $6 a year. And then you install it. You kind of need a stylus thing. This was like $35, but then I can now write on my work. Again, the 5s will cancel. 5 divided by 5 is 1. That leaves us x minus 8 equals 45, 9 times 5. Then what do? Two-step process. Add the 8. Remember, always do the opposite because we're rebellious. We're rebels without a cause. Maybe we got a cause, but we're rebels. So negative 8 and 8, that goes away. That's 0. So that's just x on this side. 45 plus 8 is 50 something, 53. And so that's our answer. We put it in, and then we check, and it says, yes, you got it right. So far, so good. So that's one type of solving. Now we're going to have one of these application problems right away. And then we've got finding the slope. And again, we'll do these in a couple ways. But what I want you to do is you see this word problem. How many saw those words and felt a little stressed? Oh, that's a lot of words. Got to read that thing. What I do, and what I found sort of naturally works for me, is to read backwards. Now, not literally backwards, but I start at the end, like, look at the end of the book and see if it's something you want to read anyway, right? Does it have a happy ending or not? So I come down to the last sentence, because that's going to tell me usually what the question is. Determine the age of a person whose target heart rate is 32 beats per second. So I'm trying to find someone's age. Now that I know what the question is, when I read through the rest of it, at least I know what I'm looking for. If I go the other way around, how many of you had a brother or sister who did the bus joke on you? Okay, so this is a blue bus picking up kids for school. Stops and it picks up 5 kids at the first stop, goes down to the next stop and picks up 7 more kids, and then it gets to the end and it picks up 23 kids. What are you just doing? You're thinking, if this is the way it works, I got to add those because they're going to ask me how many kids. What color was the bus? Oh no, I forgot about that because I was doing all the math to add the kids together. They wanted the color of the bus. Oh, it was a blue bus, right? Because I said that at the beginning. So that's the thing, is if you don't know what the question is, you start doing too many things. You get your brain working on things that are not important. Now that we know the question, we're going to focus on the age, right? So do that with math questions. Look for the question. What are they asking? Okay. And that, to me, that reduced my stress quite a bit. I know I'm looking for somebody's age. Second thing I do, I don't start reading the question yet. I see if they gave me I look for numbers, letters, and formulas. And actually, I look for formulas first. Oh, they gave me a formula. And I see an M equals 0.28 or 0.8222 minus A. Maybe that's something like age. I'm feeling better yet. So this is the age I'm looking for. So this seems to be important. And then I go, oh, here's the A. What is A? Was A years old, A years of age. Oh, A is age. That seems reasonable. M is in beats per minute. Okay, now I start getting into the question that they're going to talk about heartbeat. Okay. Determine the age of a person whose target heart rate is 32 beats per minute. 130. Oh, 132. There's a number. They're giving me something. So actually, maybe I don't even have to read the thing. I got enough. I've got an equation. M equals 0.8220 minus A. I know I'm looking for A. And in that same thing is they gave me the M. They gave me the beats per minute, 132. So I can come here and say, oh, they gave me this. This was given, 132. And so I get down to something that has all numbers with one missing piece, and I know that's the piece I want. I just need to find out what A is. Notice I didn't even have to read these ones up here. Now this is where it gets you. The maximum heart rate is the highest rate achieved during a maximal exercise. In general, you get the most benefit and reduce risk, blah, 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 blah. Do I really need to know that? Not to do the question. Maybe it's good for my health. But that's what I find is most long-worded questions, you actually don't need most of it. If you go to the end and find what the question is, you look for numbers and letters, and you look for the equation. And then you're going to say, I can solve this one. And then if you want, come back and read the story. But the problem is you start reading this and then you start thinking right away, okay, they want to know how many minutes I'm going to exercise to get there. You start answering all these other questions it's not even asking. So just in general, if you start at the end, find out what the question they want, so you know what you need to answer. Come back, look for formulas and stuff, and sometimes they even give you the answer. Thing is, I felt my sister would do that because she was a year older than me. She was smarter than me. She'd get me on that bus one, and I kept counting. Okay, I can count these kids quicker. I forget the question was about what the color of the bus was, not how many kids were on. So anyway, so now we can solve this, right? Now you could take and distribute this 8, but we just want to solve for a. This is kind of in here. This is multiplying by 0.8. So what did we tell ourselves to do? The opposite. What's the opposite of multiplying? Dividing. So what if we divided by 0.8? That's going to cancel this out. So let's divide this by 0.8. So what's 132 divided by 0.8? Somebody? 165. And that's going to be 220 minus a, right? That's gone. I want to solve for a. So what do I do with the 220? Subtract it because it's positive, right? What I do to one side, I have to do to the other. What's 165 minus 220? Negative 55. This cancels. This becomes 0. So this is negative a. Does that mean there's negative 55 years old? Well, a negative and a negative is positive. So yeah, think of this as negative 1a. So divide by negative 1, whatever. So if negative a is equal to negative 55, I just like to think about, well, that means that positive a must be positive 55. Or multiply both sides by negative 1, one way or the other. But it doesn't make sense to be negative 55 years old, but being 55 years old, that makes sense. So someone who has a target heart rate based on age from this formula of 132 beats per minute is 55. And I'll just cheat a little bit. Instead of entering answers, I'll click on this and it gives me the answer. You don't have that functionality. I know you wish you would, but here it is. Okay, so we know we got the right answer. Make sense? Okay. But I also want you to pick up, this is a strategy for working any type of word problem. Go to the end, figure out what the question is first, then look for what they're giving you as far as numbers, letters, and formulas. And it makes working forward so much easier. And again, I just did it naturally because that's sort of, I always kind of work, I read backwards and stuff. And that also teaches you sometimes what they call a disability is actually a super ability when you learn to use it right. Dyslexia is that, we were told that's a disability. My teacher told me it can be a great ability if you learn how to use it. And I found it's actually another word for it is disassociative thinking. It's something that Einstein had. He was able to come up with his ideas because he thought differently than other people. And you disassociate and you can actually think faster. And sometimes that's the thing is your brain is faster than you can write things down, faster than you can turn it into language. You just have to learn how to understand your own mind and you can have great strength. Okay, so enough said with that. Question 2. Okay, we're doing good on time. Don't ever want to rush or anything. So we'll see how all this works. So we're going to work on question 3, finding the slope. Now remember, that's the y equals mx plus b. That's the m part. How did we find slope? We could use the formula. Again, you could go to slope is rise over run, which is you're subtracting the y's in the top, and then you're going to subtract the x's in the bottom. And they just use these subsets, subletters, numbers to separate them. But I don't do it that way. I take the two numbers. Okay, 7 and 4 seem to be bigger, so I'm going to put them on top. Just makes the subtraction easier. And I'm going to put the 1, negative 2 on the bottom. And again, you could do it either order. I'm going to use this way from ancient India. I'm just going to subtract straight down vertically and crosswise. So now just what's 7 minus 1? 6. This is the harder part. What is 4 minus negative 2? Minus and negative. So you've got a negative and two negatives make a plus. So it's really going to be 4 plus 2, right? Negative and negative. 4 plus 2, that's 6. Take the x, tuck it underneath the y. So that's really, we got our rise and our run. What is 6 divided by 6? 1. That's our slope. That's our slope. Now we could have gone to Desmos and plugged this in, and it would have given us the equation, and they would have told us that m is equal to 1. You could do that way. I got used to just lining them up, straight down subtraction, and then tuck the x underneath the y. You will always get the slope correct. When I use the formula, I still make mistakes quite often. Not all the time, but quite often, because I plug things in the wrong place. Sometimes I put the x's in the top and the y's in the bottom. But when for me, it's a problem. You, it might not be. It might be the easier way for you. So that's why I put it there. But again, we'll just check it. And they give us the answer of 1. 1 is the correct answer. Again, yours may be different, but with any 2 points, just line them up, and it doesn't matter which is on top or the bottom, it will all come out in the end. So you can choose, I tried to pick the bigger one on top because that's easier for me to subtract. Okay, so we okay so far? The question to find the slope. There will be these questions on the characteristics of a linear equation. Let's do it this way. Okay, so y equals mx plus b. So rate of change. What is rate of change? What's another word for rate of change? It's the slope. It's the m part of the y equals mx plus b. So we just need to find the number in front of the x. That's our slope. It's right there. 6. Put that in. How about the initial value? We also called it the y-intercept. That's the b part of the equation, y equals mx plus b. So it's the number without the x. So in this one, what is it? Negative 4. So that if it was a plus 4, we just put 4, but with a negative, we'll put negative 4. And then the behavior, actually, I remember what it's asking, but what you can do is just, there's a drop-down list. Oh, it's asking if it's increasing, vertical, horizontal, or decreasing. Now, we didn't talk about vertical or horizontal, so we'll do that in a minute. But is this increasing or decreasing line? It's going up, right? Because it's a positive slope. Rises 6 and runs 1, if we want to think of it that way. This is increasing. Actually, we'll save it. We'll talk about, we got a horizontal one here. We don't have a vertical, so we'll talk about vertical. Okay, so how about for this second one here? Is 10 the slope? Because that's the first number? No, the slope is always the number in front of the variable. Now they're switching things here by instead of using x, they're using t, but that's a variable. So what is our slope here? Negative 7, good. So that negative sticks with it, negative 7 for our slope. What's our initial value? If I plug in 0 here, this goes away. What's left? 10. So that's the idea of initial value. It's when x is, or the input variable 0. So we got negative 7 and 10. And is this vertical, decreasing, increasing, or horizontal? Decreasing, because the slope is negative. Good. So we saw that. And again, we check all of these. There's 6, there's negative 7, there's 10, negative 4, increasing and decreasing. Here we have y equals 4a. And so the a is like x. It's our variable. what would the slope be? Positive 4. Good, because it's number in front of the variable. This is going to be a little challenge. What is the initial value? Is it nothing? Well, if I had to add something here, what could I add without really changing this? I could put plus 0, and it's really the same thing, right? 4a plus 0 is the same thing as just 4a. So what is our initial value? What's our y-intercept? 0, 0. It's this plus 0 is what our b is. It's kind of invisible. So that's the one thing with math is zeros oftentimes are invisible. Just as 1 in front of a number, if I just write x, it's actually got an invisible 1 in front, right? But it's also got an invisible 0 being added to it. So those are our invisible numbers. So we want to put 0 here. Is this increasing, decreasing, vertical, horizontal? It's increasing because the slope is positive. Good. And we could check this. There's 4, there's 0, and there it is increasing. Okay, so it's just kind of just from that equation itself. Now, if you're not sure, you could also go to Desmos and graph these. It just, again, don't use a, use x, but you could y equals 4x, and you would see that line is a line that's going up, and it goes through 0.00. Now, this last one we haven't talked about yet, but it's there is no x. Y equals -10. So what must the slope be? What made the x disappear? That would be 1x, 0x, because 0, when you multiply by 0, what happens? It turns it to 0. That's the power of 0. It's actually being, this is really y equals 0x minus 10. And 0 times x is 0, so they just take it away and just put y equals -10. So that's part of this, is you've got to be able to see the invisible parts of math. And so what is our slope? 0. 0 is our slope. What is our y-intercept? What is our initial value? -10. Now, if our slope is 0, what does that mean? Constant, horizontal. We aren't changing, right? It's not going up. It's not going down. It's just horizontal. Constant is another word for that. And we'll see these. Yep, that's what's right. That's right. That's right. Now, in the homework, you may get a question that is, so I'll do one more example, add another box down here. What if we had like x equals some number, 5? We'll just put 5. Well, where's the y? Well, it's gone. What kind of line is x equals 5? It's a vertical line. Let's think about this. If I had a graph, all I know is x is always 5. Well, here's x equals 5. The line, x is always 5. Y could basically be anything it wants. So it's a vertical line. What kind of a slope does a vertical line have? Horizontal line, we said, has a slope of 0. Increasing will have a positive slope, and decreasing has a negative slope. So what does that leave for a vertical line? An undefined slope. Because what that means is the run is 0. Notice it's not going left or right. The rise is some number, whatever. And when you try 1 divided by 0, you get, your calculator tells you that is undefined, or not an answer, or something. It's actually infinity. So if you think of when you divide by 0, what are you getting? You're actually getting the largest number. You're getting infinity, and that's what you want to think of a vertical slope. So if this question comes up, usually under rate of change, we would put D in E for does not exist. I don't know if they're going to give you these or not, but that's what it would be. The initial value, well, it never crosses the y-axis, does it? So there is no initial value because that means x would have to be 0, but 0 does not equal 5. So this is DNE, does not exist. But this last one we could put in as vertical. So vertical lines are kind of an anomaly. They're a little different. But if you see them, it's whenever you got x equals a number, that's a vertical line. And it's undefined slope, undefined y-intercept, because neither of those, and it's a vertical line. But you might just only get one of those. And again, as you go through these, what I'm doing, remember, all you have to do is get to 70%, and you'll get the full value all the way around. So it's okay not to get everything. We just want you to get the majority of things, and you'll be fine. You'll be fine. Let's clear this out. Okay. I think we got two more. So here's an application problem, basically two application problems. Okay. So in the question 5, yeah, we're doing good. They give us an equation. And again, before I start reading things, I look for equations, I look for numbers, I look for letters. They gave me this equation, got this Q thing, and then I look for the letter. Oh, Q is in after Q quarters. I still haven't read it, but I know what Q stands for. So this equation represents the balance in your college payment account. Okay, college payment. So C must be for college payment account after Q quarters. And I start looking, Q times this, it looks like, oh, I'm subtracting off money. Maybe I started with 37,000. I wish I did, but okay. So now you can kind of understand maybe how the equation's working. But again, look for the equations first, look for numbers and letters second before you get too far. So interpret the slope of this situation. So what would be the slope? The account balance is, again, when they have these drop downs, you can always just click on them. Is it increasing or decreasing? Decreasing because the slope is negative. Right, good. At a rate of, well, what's the rate? That's the slope. Remember, slope and rate are basically the same thing. Now this, be careful here, because we call it decreasing, that takes the place of the negative sign. So if you put in negative 37, it'll mark it wrong, although it's kind of right, but it would be like having a double negative, and you'll see here the answer is actually positive 37 because we're calling it a decreasing rate. So it's just one of these things that's just how it works. And this is dollars per quarter, because that's what they're telling us, that this must be the tuition charge each quarter, not each year, but each quarter. So we also have to pick the appropriate units. This is $3,700 per quarter. Okay, so that's another part of the question. And again, you could miss one or some of these and you'll still be fine. So interpret the initial value in this situation. So we look at this. What is the initial value? 37,000. After blank quarters, the balance in this account is, so how many quarters have gone by if we're at the initial value? How many quarters have you gone in school if you haven't started school yet? Right, at the 0. So at the beginning, you haven't actually started, you haven't done any quarters yet. Okay, so yeah, so that's the thing is, this intercept's always at 0. And then what was the balance? 37,000. And again, we can check our answer or just go here. Just whenever they're asking for the initial value, that answer's always basically the variable is equal to 0. That's what makes it the initial. How many quarters will this account pay for? Now this is different. So you can pay for so many quarters before the money in this account is gone. When the money's gone, what is the balance going to be? 0, because it's not a credit account. You can't go negative. So what we do is it's asking us to solve this account for 0 equals 37,000 minus 3,700 cubed. Now you could problem solve through this and say, well, if I got $37,000, if I divide by this much, it should give it, and you'll see it is, right? How do we solve this for Q? Get rid of the number without first. So we take 37,000, subtract it from both sides. So we get negative 37,000 equals negative 3,700 Q. Now we're multiplying by this. How do we undo it? We divide. And we divide by the same amount, so negative. So we're going to switch colors here. Divide by negative 3,700. What we do to one side, we do to the other. This side it cancels. So we get Q, so that's going to give us the number of quarters. 37,000 divided by 3,700. Kind of go like this, this. I think that's going to be about 10. And a negative divided by a negative is positive. 10 quarters. So see, this is taking us back to, it's an application, but we're just solving an equation. You had to know to plug in the 0 for the C. So it'll be gone in 10 quarters, exactly 10 quarters. Let's go here. Yeah, 10 quarters. Now, yeah. If we got 10.7, what does that mean? You really can't go for 0.7 of a quarter. It would still be 10, right? Because you ran out of, you don't have enough money for a full another quarter, is what that's saying. So I don't think they'll do that to us, but that's it. Okay. This is one I'm going to recommend that we go to Desmos with, but I'm going to show you how to set this one up. Okay. Tuition costs. So again, I go to, what am I asking for? So I go to the first question, C equals, determine a linear equation to represent the cost of tuition in terms of X, the number of years since 1990. So C equals MX plus B. Okay. And again, C could be Y. So this is what we're looking for here. I'll just go Y. So now I come back to look at what they gave me. In 1990, the cost of tuition was $105 per credit hour. In 2003, the tuition had risen to 235 per credit hour. It represents the cost of tuition in terms of X, the number of years since 1990. So X is years. So the years, so I got 1990 is my X, and the Y is the cost of tuition. So that must be given in dollars per credit. So that's one point. The other point is 2003, 235. Okay. So on these linear equations, what you're going to see is whenever the information, the data you're given is really always going to be 2 points. But the numbers, notice they gave us 4 numbers. This is telling us X is the years. But they're a little bit more specific here, years since 1990. So let's think about it. In 1990, how many years have gone by since 1990? 0. Right? In 1990, it is 1990, 0 years have gone by. So what they're doing is, and I compare this, there's 2 systems currently in use. There's more than 2 systems, but 2 that I'm familiar with. This is either the year 2000 or 2024 over here. When I go to Thailand, they call it 2024 to go with the rest of the world, but in their own system, they've actually got it as 25 something, 65, I think it is. I get off. It's based on the year that Buddha was born, because they're a Buddhist country. So they count time from the time of Buddha. In the West, we're counting from the time of Jesus Christ. So you can decide whenever you want to make year 0, depending upon what you want to do. And centuries ago, they used to, every time there was a new king, that became year 0, and then this was the 56th year of King Hoo-ha, and or whatever, so that we could make any year 0 we want. So what we're going to do is it makes the math easier if we make 1990 year 0. So if 1990 is year 0, what is year 2003? I like using calculators, so what I'll do is all I have to do is subtract 1990 from each year, and that will tell me how many years since. And you'd be right, it's 1990, so that should be 13 years. But I always like to do it with the calculator because so 2000 minus 1990 gives us 13 years. So this is the year 13,235. See, I did it. Transposing numbers again. 235. And again, you could find the slope, the rate of change. You could do this all by hand if you want, or we could jump over to Desmos and it will take care of it for us. So since we've already got Desmos open, remember these numbers: 0, 105, and 13,235. Write them down somewhere. We're going to go back to our Desmos. The nice thing is it's all set up this way. I don't need this one, right? All I got to do is go up to my table here and change my values. So I put in 0 and what was it, 105? And then down here, I put in 13 and I put in 235. Now the thing is I don't see any points over here. Can anyone tell me why? Too small. My window's too small, right? This is, the Y is 235, but my Y is only going up to like 7 or 8. So what I do is I move this thing out of the way. There's this little wrench. I can make it bigger. So the x-axis, notice I'm going from 0 to 13, so I should maybe go from -10 to, I'll go to 20, is more than 13. This is the number of years. My y-axis, okay, that's a negative, that's fine. I need to go to at least 235, so how about if I go to 250? If I do that, and then actually I want to turn this off, so I'm going to click on this for right now. Let's see. There we go. Turn the line off. 0, 105. Oh, there it is. I was missing it. So there's the point 105. Oh, yeah, that looks about right. And here's 13. Yeah, that looks about right. That's 10, 11, 12, 13, 235. So I've got my 2 points. Oh, I guess I could have left the line on. But, oh, if you click and you could actually change the color. Let's make it a blue line. Let's turn, oh, let's see. Did I get it to turn back on sometime? Okay, depends on your mouse. Just click once, there we go, and it's blue. Now I've got the line connecting it, but more importantly, what else do I have? I've got the equation of this line. The slope is 10, the y-intercept is 105. That's because I made that first year to be the initial value. So that 105, oh yeah, that's where that came from. So my equation is going to be y equals 10x plus 105. Okay, so now I can jump back over here, and I could put c equals 10x plus 105. I'll see that's the correct answer. So I found that equation. So far, so good? Okay.
decimal, the second part, the equation,
That one you have to put in,
because I put in that.
right. So then you have to put in, using the keyboard, there's a Y and an X in the main thing, so you just put in Y, but
and
you,
then
the tilde thing, so
oh, okay.
that's, yeah. And you need Y1,
So Y1
and then the tilde, and then one. Yeah, and it even did it there. And then there's a, yeah,
and then
mx plus mx1 plus b. So yeah, just put in,
MX1
yes,
plus
plus b. And the thing is with Desmos, it's tied to your Google, or you can have it tied to your Google account if you sign in with your Google account, which I usually do. I don't think I'm signed in right now, but let me go ahead and well, it's too much work. But once you're signed in, you can save things, and then when you have them saved, they will appear over here. So I would encourage you, put it in one time, and then save it, and then whenever you need to do a problem like this, just go in and pull it up, so you don't have to redo it. And you can use your Scottsdale is also a Gmail account. So as a student, your Maricopa account is a Gmail account. So if you sign in with it, it saves it. I think I've got everything saved under my ASU account, which is also a Gmail account. Anyway, that's how you can do it. Let's go ahead and get this finished up. So then, oh, that's our last question anyway. In the year 2008, tuition will be what? Well, that's after 2003 and it's going up, so we would expect it's going to be more than 235. How do we figure out? Well, again, we take 2008, we subtract 1990 from it, which gives us 18 years. So that's our X value. So we just take our equation, C equals 10, we plug in 18 for X, and we will get our answer. Oops, I guess we don't need a parentheses there.